Yes. Okay, Pati, good afternoon. Yes. At last day, we just, yeah. Shall we move for the lesson? Yes. Okay, did you remember last day we discussed about the main component of the CPU? That's regarding to arithmetical logical unit, control unit, like that. Okay, there are a heavy important thing with the system clock. That clock is actually going with the control unit as well as memory registers. They collected that clock system clock is runaway things. It is collected with the what computer signals. So system clock is used to produce timing signal on the control bus. So this vital synchronized take place without the clock is computer would be simply clash. Okay, you just write down this. We will discuss later on. The system clock is used to the produce timing signal. It's used to produce timing signal on the control bus. To ensure this, it is vital synchronized take place. It's vital synchronized take place without the clock. Computer would be simply clash. The computer simply clash. If they are not having clock, it should be simply clashed out that one. So it's very important. Okay, all the things going on the clock timing. Okay, it's just like a timing retail thing. If they are not having clock, the computer should be clash. So always system clock is used for the produce timing signal on the control bus. Okay, keep in mind to ensure the vital synchronized speed. And it's very important. The RAM hold all the data and the programs. The RAM hold all the data and the program needed to access by CPU. Okay. So the RAM is often referred to the immediate access store. The CPU takes RAM and the program in held on the backend store and put them RAM temporary. Okay. Actually, the RAM is often referred to as immediate access store. And also CPU takes the data and programs held in the backend store and put them into the RAM temporary. Okay, this kind of thing. So the term is often referred to as immediate access system. The CPU takes data and program held in backend store and put them into the RAM temporary. Okay. RAM, it is a temporary memory. When you are what? Power goes down. When when they are having power clash, the RAM data will be erased. We call it that one non-volatile memory. Okay, we call that one as what? Non-volatile memory because when it is power off, your RAM data will be erased. Okay. So this is done because read-write operation can carry it out using the RAM are considered faster than the read-write operation back in store. Okay. So consequently, key data needed to application will store temporary RAM to the so this is important. The key data needed by the application will be stored temporary RAM to the consider the speed of the operation. So all the data when you are running the application data should be temporarily stored on RAM. The instruction data are temporarily stored on the RAM. Otherwise, it does not what run in the application. They are not having chance for running application without RAM works. So RAM temporary what stored instruction data for running application. All the things. So it's a very important RAM access thing. So it's very important. Can you write down these things? This underline part? Yes. Next, we will carry out the register. These are very, very important thing. Okay. Yes. The system clock, immediate access store, backend store, something like that. The RAM consequence. Okay, write down. Yes. Write it down. Yes. So like that, there are using system clock. There are using immediate access store. There are using backend store like that. Okay, important thing. Okay, write it. Yes, I think you wrote yes. And next thing is registers. Yes, you can use like that system clock, immediate access and backend store. Okay. And the next thing is registers. Registers is the memory, the fastest memory that can be seen on. Okay, so one of the most fundamental component of the one human system are the registers. So registers is very low space. Memory capacity is very low, but this is one of the most important, that richest and fastest component of the computer. Okay, so one of the most fundamental component of the one human system are the registers. So registers are one of the most fundamental component. So register can be general, special purpose. Okay, so register can be general or special purpose. So it can be general or special purpose. So we will only consider the special purpose registers. A full list of registers used in the textbooks are summarized table. So registers can be summarized like this. Okay, they are having several types of registers. First of all, write this on underline part. One of the most fundamental, one of the most fundamental component of the one human system are the registers. These are very important. Okay, that's why I write in all the thing for them. These are very, very important. The components of the computer, these are very important. That's why I write it. So one of the most fundamental component of the one human systems are registers. Most fundamental component on the one human systems are registers. So register can be general or special purpose. So registers can be general or special purpose. It can be used for general purpose as well as special purpose. Yes, write it down. So one of the fundamental component of the one-name systems are registers. Register can be general or special purpose. Okay, it's used for the general or special purpose. So in this table, you can see there are having several types of registers. Current instructions register, we call it that one CIR. So what is the purpose of that function? This register is a current instruction being decoded and executed. The main thing, it's quickly gathering instruction for application. When you are running some application, it's important. Like that one, this kind of register is for current instruction being decoded and executed. And the accumulator. Next thing, the accumulator. We call it ACC. This register used when carrying out ALU calculation, that arithmetical and logical unit calculation are running through this accumulator. So this register used when carrying out ALU calculation. It is stored data temporarily during the calculation. During the calculation, it can be stored data temporarily. Very important, ACC. And the memory address register, we call it MAR. We call it MAR. MAR is memory access register. So memory address register stored address of the memory location currently being read at the written to. So this register is stored the address of the memory location currently being read from or written to. Read from or written to. Both sides. So memory address registers are currently used read on or written to. So memory data buffer register. We call it that one buffer. Memory buffer. Okay. The register is stored data that has just read from the memory. When you are just reading from the memory, that data about written onto the memory. So next thing is program counter. PC. This program counter, this register is stored the address where the next instruction to be read can be found. So most important, this register is stored the address where the next instruction be read can only. Can you write down this table? Special purpose registers. Just write down this. You can summarize this. No need to write all this. You can summarize and write it. Doesn't matter. Okay. Can you write down this register table? This is very important. I give time. I give 5 minutes of time. Can you write down? That's very important. There are mentioned the current instruction register, accumulator, memory address, memory data buffer register, program count. All of them are clearly mentioned above register types and the details. Okay. Functions. Please write down that. Here the special purpose registers, the function and their works. Okay, write down. Yes. Write down it. Yes, I will write it down. Yes, I think you wrote that down, no? Yes. Okay, so that's about current instruction register, accumulator, memory address register, memory data buffer register, and program counter. There I have several types like that. So current instruction register we call it CIR, accumulator ACC, memory address register MAR, memory data buffer, take the MDR and PC. Okay, program counter. Like that one, there I have some registers. That's important. So like that, there are install current instruction like that. Yes, right. I give that. Write it. Okay, like that you can write there. This kind of registers there. We will move forward. Yes. Yes, that's register. That next thing is very important about the system buses and the memory. Okay, write down system buses and memory. Earlier also we discussed they are having some system buses. What are they? Mainly previously we said they are having control bus, address bus, and the data bus. Mainly they are having control bus, address bus, and the data bus in the system bus. The mainly they can be connected for the CPU, memory, and input output ports. What are they? They are connected to the what CPU, memory can be RAM and ROM, that hard disk and all that is, and the input and output. So like that one. We discussed about component like buses. Figure 3.2 shows these buses used to the connect to CPU, memory, and the input output device. So like that one, the buses. The system buses are connected to the CPU, memory, and input output device like here. Okay, first of all, can you draw this figure? Again, I will give some time. We are writing a lot of things, no? Yes. Please, can you write down this figure? First of all, write down this figure. We discuss about later on. Okay. Draw this figure. I give you 2 minutes of time, 2 3 minutes of time. First of all, taking time. It's okay. You can use color pen. This is better. Draw this figure. Okay, like that means we can use for buses. They are connected to the CPU, memory, and input-output ports mainly. Yes, right. Okay, like that you can draw the figures, no? The connectivity for the control bus, address bus, and the data bus, that system bus into the component of CPU, memory, and the input-output ports. Okay, yes. So actually, when we consider about memory, okay, the computer memory made up the number of what partition. So each partition consists of the address and the content. Okay, write down next part is the computer memory. The computer memory is important, made of the number of partition. So each part consists of the address and the content. Okay, each part you can see in the 3.2, they are having all the thing, all the memory, RAM or ROM or anything, all the memory should be consist of what? Address and the content. They are having the address and the content like that. So it's showing in like that. So all of them with the 8 bits of the content, it is a real computer memory. The address and its content are actual much larger than this. Address and the content actually much larger than this. So address will be uniquely identify every location. That's also important. The address will be uniquely identified in memory location and content will be binary stored of the location. So they are stored as binary form. That means 1 and 0. So always that address will be uniquely identify every location. Address can be uniquely identify every location in the memory and the content will be binary value stored each location. And after that, the computer can they are having the binary value of the container with the each and every stored location. So write down these underlined parts. Write it that underlined part, please. So computer memory is made of the number of parts. So each parcel consists of the address and its content. So the address will uniquely identify every location in the memory and its the content will be binary value stored in each location. The content in the binary value is stored in each location. So now consider the example how MAR MDR register can be used when carrying out the read and write operation from the memory. Here the what? How works the MAR and MDR read and write the things? First of all, we will see. Okay, so write down this underline part. Now I wanted to consider example how MAR MDR registers. First, consider read operation. First, if try to read the message, read something, we will use memory section shown in the table like here. So suppose we wanted to read contents of memory location, like the two registers used as follow. Here MAR, the address of the location 111.0.0.1, read into the MAR. Okay, first of all, according to that, they are read this signal. Okay, so mhm. Okay, so we will write that. How we will study from this. We wanted to read content memory location. This one. The two registers are used as follow. And write down these things. The address of the location. Read from the written into the MAR like here. And the thing. Read signal sent to the computer memory. First of all, it's read signal from here. It's sent for the memory. The content of the memory location are then put into the MDR. The content of the memory location then put into the MDR. Next, in content should be put for the MDR. Okay, write this underline part. First of all, we wanted to read the content of the memory location. The two registers are used and follow. The address of the location, like here. And next, it reads signal and sent to the computer memory. And this content memory location are then put into the MDR. Okay, write down them. Write it. Write it down. Yes. Underline words. Yes, write down that. First of all, we wanted to read content of the memory location like that. The two registers are used and follow. Firstly, they are having MDR, sorry, MAR, memory address register. They are taking the address. They are read the signal to the sender computer memory. The content of the memory location are then put into the MDR. That content of the memory register then put into the MDR, like here. Firstly, it's read by what? Read by memory, MAR. Here, this part, address. The content, they are having content for that one. So that's content right on the MDR. The content memory location are put into the MDR. What is the other one? The address of the location. Read from the MAR. The content of the memory register. Content, this part. This part goes for the MDR. Here, it's going for MAR. This part going for MDR. Clear? This part goes for the MDR. So, that's a reading part. Next, you should be consider the write operation. Write down that, write all the underlined parts, okay? Yes, write whole underlined part, all these. Okay, write down them. We will go whole underlined parts. Yes, I think you're right that one. No, that's about reading part. You can read like that. Data will be read out there. First of all, read. Now they are having. Now consider writing part. As previously, firstly, firstly, the data to the stored first written to the MDR. Firstly, it's written for the MDR, that thing, the data, record data. And this data has written to the location with the address in the MAR. Next, it written the location with the AMP action. Okay, finally, uh, write signal to the written for the memory location. Okay, write that there. Yes, write down then. The having instruction to write operation. Okay, so data is stored in the first in the MDR, like here, and next the data written in location with the address written on the MBR. Okay, next let's go for the MBR. Firstly MBR, next it go for the MBR. Okay, write it down for this. Yes, write down. Yes, write it down. Yes, like that one. The data is stored in the first written into MDR, and next the data has been written into the location with the address now written in MAR. Finally, uh, write signal to send the computer memory and value like that. Okay, right there, please. Okay, so I think you wrote. Yes, we will move forward like that. There are heavy main thing, and next thing that input and output devices. As previously told in the what? Yes, just write down input and output device. Quickly go. Okay, input and output devices. Okay, input and output devices will be covered in more details in the section 3.2. Just their main method to enter the data into getting data out for the computer systems. Enter data and getting data out for the computer system. So input device convert external data into the form of computer can be one understand and can be processed. that can be input output device can be understanding computer process. Okay, output devices result processing in the human understanding, like printers, monitors, and loudspeaker. So just right. They are the main computer entering data into getting data out for the computer. Enter the data and getting out. Input, enter the data thing. So when we wanted to get it out, we are using output devices. So input device convert external data into the form of computer can be understand, can then process like keyboard, touch screen, mouse, microphone like that. Output devices show the result computer processing in the human understand like printer, monitor and loudspeaker. I think you already know this one. Just write down. Yes. Write it quickly. After that one, we will wind out today. Yes. Write down quickly. So they are having mainly input and output devices like that. Write it. It's the main process of input and output devices. Input devices, we needed to input data for the computer. If we wanted to get data from computer, we are using output devices. Write it. Yes, that too mainly have input and output devices. Okay. So they are having a method for entering data or like using keyboard, like mouse, microphone, like that input devices. They are taken as what? Input devices. So when we wanted to enter something for the computer, we are using input devices. And when we are use data out from the computer, we wanted to take data from the computer outing that calling output devices. Something like printer, monitor, and the loudspeakers. That like printers, monitors, and the output. Okay, so output devices show the result of the computer processing the human understanding, like printers, monitors, and the loudspeakers. Okay, like that one, they are having main two input and output devices. And next, they are having system buses, address bus, and the data bus and control bus. We will write about them later on. Okay. So I think there are a lot of important part this one that address the buses, input buses, and fetch decode execute cycle. These are very important. Okay, these are very important, and they are having a lot of theories included these things. Okay. So I think it's almost time up now. Yes, I'll wind out the session for today. So you have to leave right now from the school now. Yes. So I will wind up the session for today. So we will write other thing on the next day. Okay. So I will wind out. See you on the next day. So good afternoon. See you next day. Okay. Good afternoon. See you next day.